Hello everyone and welcome to Nurses Lecture Room YouTube channel. My name is Mercy Mary, popularly known as the Nurse with the Difference, and I make learning easy and accessible for students. Today we are going to be talking about hemolysis. What is hemolysis? I know a lot of students are having challenges comprehending the breakdown of red blood cells, which is hemolysis. But before the end of this class, you will be able to tell me more about hemolysis. But before we go, kindly click on the subscribe button and turn on the notification button so you don't miss out. So what is hemolysis? Hemolysis is simply the breakdown of red blood cells. Hemolysis is the breakdown of red blood cells. The lifespan of every red blood cell is 120 days. The lifespan of every red blood cell is 120 days. After 120 days, they are being destroyed in the reticuloendothelial cells of the spleen. They are being destroyed where? In the reticuloendothelial cells of the spleen. What happens? What happens is that this hemoglobin, which is the most important pigment in the red blood cell, breaks down into two parts: the globin part and the heme part. The globin part is the one that has the protein. When you hear globin, what comes to your mind should be protein. So what happens to the globin is that this globin breaks down into two in the liver. It could break down into amino acid, which is reused again by the body, or it could break down into urea or uric acid, which are excreted out as waste products. What did I say? The globin in the liver can break down into amino acid, which is reused again by the body, or it breaks down into urea or uric acid, which is excreted out of the body. Let's now go to the second part, which is the heme portion. This heme portion actually forms two things. It's either some part of the heme is forming iron, or the other part of the heme is forming what we call bilirubin. This iron that is being formed is taken to the liver and stored as what? Ferritin. This iron is taken to the liver and is stored as ferritin, and it is reused again by the body when needed. Why this bilirubin in the spleen is being oxidized to what we call bilirubin. Bilirubin is a greenish pigment, while bilirubin is a yellowish pigment. I guess most of us are familiar with bilirubin because bilirubin, when there's increased bilirubin in the body, it results in what we call jaundice. So bilirubin is then oxidized to bilirubin. This bilirubin is not soluble in water. This bilirubin, as I said, is not soluble in water. What happens is that plasma protein helps to transport this bilirubin to the liver. This bilirubin is then combined, it joins itself with plasma protein, and they are moved to the liver. When it gets to the liver, what happens is that the liver puts what we call glucuronic acid in the bilirubin. It adds it. So when it adds glucuronic acid to the bilirubin, 80% becomes soluble. That's those that get that glucuronic acid. Those that have that glucuronic acid, they become soluble. While those that don't have the glucuronic acid are still insoluble in water. Be it the soluble bilirubin, be it the insoluble bilirubin, what happens is that they are being transported by the biliary tract into the duodenum. They are being transported through the biliary tract into the duodenum. From the duodenum, bacteria act on it and it's been transformed into stechobilinogen and is excreted out as feces. Yeah. While some of the bilirubin reabsorbed into the bloodstream, they go back to the bloodstream from the intestine, then they form what we call urobilinogen and they are excreted out by the kidney. I hope we are able to understand this process involved in hemolysis. First of all, there's a breakdown of the hemoglobin into the heme and the globulin. This globulin portion forms what we call the amino acid or the urea or uric acid, which is excreted out of the body. Then in terms of the heme has both the iron and the bilirubin. In terms of the heme has both the iron and the bilirubin. The biliverdin is being oxidized into bilirubin. The bilirubin is then transported with the help of plasma proteins into the liver. So when it gets to the liver, 80% combines with glucuronic acid to form soluble bilirubin. They are not able to dissolve in water. While 20% are insoluble, they are not able to dissolve in water. Then they pass through the biliary tract to the duodenum, where it's a bacteria acts on it to form stechobilinogen, and also some parts dissolve. They are being reabsorbed into the bloodstream to form what we call urobilinogen. I hope this this video help you understand the breakdown of red blood cell properly. If there's any question, kindly drop on the comment section. Don't forget to listen to our previous voice notes on blood and erythropoiesis. Thank you very much and do have a wonderful day ahead.